Hello, my name is Jessica Burke. This is my senior project entitled Sky CSR. The agenda is as follows. We're going to go through the background plus data collection and then into the design and web application development plus the testing, trials, and feedback to finally conclude with a little bit of a financial justification and psychology of waiting. So here's the recap of the project so far. Aircraft utilize specific frequencies to relay messages. It's pretty much used all over the industry. They use it to communicate with other aircraft, with air traffic control, and then with these things called fixed base operators, which is called FBOs. The problem is that these broadcasts have physical limitations. For instance, when aircraft come into San Luis Obispo from the north and they send a broadcast to the FBO right here, they sometimes lose that message simply because there's a huge mountain range between them coming in from the north and us here at the FBO. So what this means is that any lost messages make it really difficult to get their needs met on the ground. They may call in for a quick turn, which they'll need fuel and a rental car so that their passengers can out, and then they can turn around and do what we call a turn and burn and go to the next airport to pick up more passengers and go somewhere else. If we don't get that message, there could be a chance that they have to be on the ground longer. So why is it important that we address it? Well, if we miss that call, we risk them delaying on the ground. And there's no other industry on earth that better exemplifies the statement, time is money, better than that of aviation. According to Avinode, the most popular model of jet in 2012 was the Citation XL, which is a quote unquote middle of the road luxury jet, which took off a total of 144,302 times at the rate of $3,388 per hour. In a business where it costs nearly $57 a minute to keep the engines running, efficiency and streamlining the process is the top priority, which is why planning, minimal movement, and efficiency is a top goal for ground services. So to begin the project, I first needed to collect some data. As you can see, this pilot survey, on the left, how often are pilots delayed? So they're not delayed too often, which is great. Most of the pilots that responded, which I had a total of 34, responded that they're delayed maybe 1 to 2 times a month, while a portion, significant enough, answered that they were delayed 2 to 5 times per month. The other question, it was only a 3 or 4 question survey. The other 2 questions had to deal with like what they fly, so if it's Part 135 or Part 91, and then what airport they're based out of. The next question addressed the reasons for the delays. Most pilots responded that they felt that the reason they were delayed was because of a lack of people. A large portion of pilots also felt that there weren't enough ground support equipment to meet their demand for the customers. Another significant portion responded that their fuel order had actually been forgotten or just never executed, which causes them to be delayed. There was additional data collected, such as the volumes of fuel sold per day, the number of aircraft served per day. This was all like uplift reports and accounting data, and it all really served a purpose later on during the financial justification and not so much in terms of the web application development. So I'll get into it later. So after the data collection, I began to develop the algorithm for the web application. This picture shows the logic behind the process or behind the application when the arrival is scheduled. The application branches off into 2 main processes. The top process is for aircraft who are quick turning. These aircraft receive a higher value than the aircraft staying for a couple days, so the bottom row, because they need services, but they need them quick. They need to be prompt and they need to be precise. The next step is to calculate the value based on how many services they need. So it's this little box right here. Each one of those is added up, multiplied by a value of 10 if they are quick turning. If they are not quick turning, it's multiplied by a value of 1, and then they're weighted based on how much they need, which shows up on the FBO home screen. So now that I've got this general idea, I got to actually develop the web application. So here's the schedule arrival. This is what pilots will put into the actual web application, which will calculate what they need. This is all the basic information that a customer service representative will need. It's got the airport time, the actual FBO, because there may be multiple FBOs on the airport, the email, a tail number, the type of airplane, because Gulfstream, totally different than a Cessna 172. If it's quick turning, which is that 10 value of 10, the arrival date, and the services needed. The next was a schedule fueling. This actually came up during the first iteration, which I'll talk about a little bit later. But during the first iteration, it became noted that having a streamlined process just for fueling for local FBOs and local pilots would be really helpful so that they don't have to, keep putting in an arrival and answering all this information they don't really need. So after that, we have the FBO profile creation. This is where the FBO will come through, create a username, put in their frequency that they monitor, make a password, telephone services provider, just kind of the general gist. This is when they log in, this is what they see. The arrivals or the scheduled arrivals. So the scheduled arrivals is where that information that the pilot put in, this is where it shows up. And it shows up with a level, so it's a low value. It shows what airport, what FBO, who it is, where to contact them, the tail number and the airplane type, and then all of the services. Now they can select on the grid view, and this underneath them is this like little area where it says the name and then who it is. And what you do is you can send them a confirmation. So thanks, got your arrival. We'll see in a couple of minutes. Or, hey, we saw that you needed a GPU. Our GPU is down right now, so maybe we can figure something else out for you. And then they can send that confirmation and move on. So next is the scheduled fueling pages. And, it's a little bit the same. It's basically that you can put in that scheduled fueling and people will be able to see exactly what it is that needs to be done, who needs it, what the tail number is, any special requests or anything like that. And this idea came up during the second iteration or the first iteration, that having that scheduled fueling would be a better streamlined process. And so what the idea was is that each of the fuel trucks would have an iPad that would be open to this particular page, and they'd be able to confirm and finish it as the fueling was being processed. And that way the customers would be able to see, oh, it's been confirmed, so they're working on it. Oh, it's been finished, I'm good to take off. So the first iteration was an interesting test. The pilots I sat down with have all been in aviation for well over 10 years, and they seemed really overwhelmed at the idea of having another application to use. But at the end of the day, they all agreed that if this web application was integrated into an existing application, they would absolutely use it. The diagram on the screen is kind of a pictorial view of the current way versus the way that Sky CSR would communicate needs. So on the top, you have the customer who has to telephone or email into the customer service representative or use frequency, which then has to be radioed to the line service technician. Whereas the customer could just put in the order, the line service technician can see it, but the customer service representative, who's taken totally out of the equation, can at least monitor what's going on so that they have a general overview of what's going on. This is just a general pictorial view of what's going on. So during the first iteration, this is where the entire idea of the scheduled fuelings, where the line service technician could basically confirm and finish the fuel without ever having to even involve the CSR. So the second iteration was a little bit more qualitative. There was no significant changes to the design other than adding the controls in the upper left corner, which made it more user-friendly. And then the discussion revolved around the general usability and the applications already on the market. So applications on the market, we have TrackPack in the top left, we have FlightAware in the top right, which is just the free version of TrackPack. TrackPack only shows the tail number, the type of aircraft, the time or estimated en route time, and then the arrival time. Doesn't show anything else, no needs, no nothing. Flight Plan is basically the closest that it's come to my application, but the problem with Flight Plan is that they send faxes. They don't actually send web application, or they don't send, notifications that something's coming in. And typically FBOs just disregard the faxes, or they just never see them. The final option is ForeFlight, which is probably the most expensive option, but it's extremely cool because it's got all the great applications, but it doesn't have any kind of FBO support. So the problem remains. None of these apps offer any kind of FBO or planning support system. It's all purely from the pilot side in terms of planning, which is where Sky CSR comes into play, by building that bridge between the needs of the pilot and the planning needs on the ground to make sure that services are timely and prompt. So next. Okay, so next is the financial justification. It's hard to quantify how much a lost customer would cost the company, but using the data collected from the accounting department, I was able to calculate some rough figures based on averages. A single Avgas customer will on average spend $185 per trip. If the FBO was to cause a dissatisfaction somehow, there is always a possibility they lose the customer or that they simply don't visit as frequently, which is quite a bit of a lost cause. For jets, this is somewhat a different story. A jet typically doesn't have the same discretion that a 100 low-lead customer has, basically because trips are for business, which means that they have to go into the airport or FBO regardless of if they have a good relationship with them or not, because it's what the customer wants. Even still, the average jet brings in $1,300 in jet sales per trip, so it's important to keep them happy. So another dimension to look at was the wasted movement. The aspect of this is that the FBO would have to scramble every time fuel or other services aren't ready, meaning that instead of using and positioning them prior, they have to go around and scramble and make sure that everything is working properly, which means that they have to make extra trips back and forth. This can cause extra movement by the line service technicians. For the justification, I looked at simply the movement between the FBO office area where all the line technicians hang out and the fuel trucks, which by FAA mandate has to be 100 feet away from a building. So given the number of uplifts and distances from the FBO, the company will pay nearly $2,000 a year in walking alone back and forth. And that's just to the jet trucks. That's not even to the 100 low leg calls or anything like that. So finally, on a more humorous note, during one of the discussions with one of the pilots, waiting was brought up into the conversation. The general consensus is that pilots understand that they're going to have to wait for services. In some of the high-impact FBOs, there is going to be a wait. You know, you go into San Francisco, there's probably 5 or 6 Gulfstreams waiting for having one GPU. You're going to have to get used to waiting, which is why they always schedule them for about an hour earlier than their departure. But when a pilot brought up the fact that he knew the FBO was busy, but he still saw line techs walking slowly or standing around, he would go out of his way to make their lives miserable, basically parking a plane in the most ridiculous spot he could possibly find. Thankfully, this pilot is on the outlier in terms of pilot behavior, but the larger point should be noted. If it's busy, don't look like there's nothing to do. This plays into the psychology of waiting that people understand fairness. They're willing to wait their turn, but if they're waiting and they see people who are supposed to be servicing an aircraft that are in front of them, standing around and laughing, they will not be happy. Okay, so that's my project. Basically, the application was well received. The next steps for it is that I really need to integrate it into another existing application. But, you know, barring being further built into another application that's already out there, it was very well received. So I'm happy with it. Okay, that's my project. Thanks for listening.